Hi guys, welcome to lesson 3.3 where we talk about implicit differentiation. Now before I even get into this lesson at all, something that I want to remind you from last chapter when we introduced derivatives. When we introduced derivatives, we said that there are a lot of different ways to write derivatives. To remind you of a few, we could write them as y prime, we could write them as f prime of x. Then we could also do this dy dx. This is the one that we're going to be focusing on this lesson. Now what dy dx actually means is take the derivative of y in terms of x. So take the derivative of y in terms of x. That's what that dy dx actually means. And we're going to play with that quite a bit more today. Now, implicit differentiation is where it says it right here. So far we've been doing examples like this. Basically examples that were functions. They pass the horizontal or vertical line test, that kind of ideal. The x is explicitly express y in terms of x. But now we're going to start to do functions, or I should say equations, that aren't necessarily functions. So they don't pass that vertical line test. Now here's what we're going to start with. Let's start with these warm-up examples. So far, if I wanted to differentiate this, I would say y prime equals 1. We're pretty good at that. But I'm going to rewrite this dy dx equals 1. Okay? Let's try the next one. This would be y prime equals 2x. And once again, I'm going to rewrite it. Dy dx equals 2x. Okay, let's try number 3. Now we're starting to get into some chain rule. So this one, derivative, this would be u squared. So I take the derivative of the mommy, 2u, times by the derivative of the baby, which is 2. And then plug the baby back in. So 2 times 2x minus 1 times 2. And then once again, I'm going to change that to dy dx. And I'll just simplify some stuff as I go. Okay? Now let's do this one, number 4. Number 4 is also chain rule. It's the same chain rule with u squared. So y prime is going to be derivative of the mommy times by the derivative of the baby, which in this case would be f prime of x. Because we don't have an actual equation, so we're just going to write it like that. And then we plug the baby back in. So 2f of x times f prime of x. And then I'm going to change it to dy dx again. Okay, so far so good. Now we're going to do number 5, but let's do this very slowly. I'm going to take the derivative of the left-hand side. Derivative of x is 1. And then the derivative of the right-hand side, I'm going to do just like this, where y is f of x. So I'm going to get 2y times y prime. And I can see that by just taking this one and replacing the f of x's with y's. Now, let's rewrite this. So this would be 2y times dy dx. And the reason you can think of this x as a 1 is because this is dx dx. I took the derivative of x in terms of x. That's what we wrote up here. Take the derivative of y in terms of x. So this is taking the derivative of x in terms of x. And top and bottom cancel out, and that's where I get that 1. So this would be my final answer to number 5. 2y times the derivative of y in terms of x. This is the derivative of x in terms of x. So that is a little warm-up example of implicit differentiation. In the next problem, or in the next video, I should say, we'll go into a little bit more examples, a little bit more in depth into what this means.